So today we're going to have exercises on derivatives of algebraic functions. Find the derivative of the given function using limit definition of derivative or four-step rule, no? Using, in other words, using increment method. Let's say we're given f of x, and that is equal to 5 minus 7x. So what is the derivative of this? So using limit definition of derivative, we have what, guys? So how do we define f prime of x? It is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, no? Now, of course, we assume that for f prime of x to exist, this limit must exist, no? Get it, guys? So, what is our f? That is defined by 5 minus 7x, no? So, let's find f of x plus delta x. So, that is 5 minus 7x. But what is our x here, guys? X to be replaced by x plus delta x, right? X plus delta x. Then minus, what is our f of x? The given function, 5 minus 7x. All over delta x, okay? So simplifying the numerator, we get, so limit as delta x approaches 0 of the numerator gives us simply negative 7 delta x, right? Because this will be eliminated, no? Negative 5, positive 5. 5, negative 5, additive inverses of each other. This is negative 7x, positive 7x. So this is eliminated with this, no? Am I correct, guys? So we are left with what, guys? By simply, what, guys?
Delta x over delta x.
So we have negative, no? Negative 7 delta x over delta x. And then delta x is canceled out. What's now the limit, guys?
Negative 7.
Negative 7, no? And that is our f prime of x. So how do we interpret this, guys? This is the slope of what? Of any tangent line of a tangent line to any point on the line. Because if you have a line as your function, the tangent line there is the line itself. Am I right, guys? If you have a linear function. So whatever the slope of this linear function, which is negative 7, that is the expected derivative. No? Okay? Let us have number 2. So let's say our f of x is given by 3x minus x squared plus 4. So what is the derivative? So by limit definition, of derivative, we have f prime of x is equal to limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Okay? So our f of x is given by this quadratic function. We want to know f of x plus delta x, meaning we're going to replace x by x plus delta x. No? So we have 3x plus delta x minus x plus delta x quantity squared plus 4, and then minus f of x. Our f of x is 3x minus x squared plus 4, right? All over delta x as delta x approaches 0. The numerator can be simplified into what? So we have 3x. So this 3x will cancel with or will be eliminated with negative 3x here. Then we have this 4 is additive inverse with this negative 4, no? So when we add 0, so we are left with what, guys? Delta x approaches 0, so limit of what? Of the numerator is, or what's the expansion here? So this is simply 3 delta x, right? While this one, when we expand, this is x squared plus 2x delta x plus delta x quantity squared, preceded by negative, so everything will be negative. So minus x squared minus 2x delta x, and then plus delta x quantity squared, and then plus x squared all over delta x. Okay? So there are, I think, still terms that are eliminated. And if you're going to factor out delta x in the numerator, it will cancel out with the delta x here. Am I correct, guys? So what will be left? 3 minus 2x plus delta x, right? Limit as delta x approaches 0, 3 minus 2x plus delta x. Am I right, guys? What is the limit? For the first term, 3. For the second term, negative 2x, because x is considered constant inside the limit, our variable is delta x. So delta x is 0, no? As delta x approaches 0. Okay? So finally, we have 3 minus 2x. So this is our f prime of x. Get it, guys? Okay? Any question with that? Okay, so number 3. Let's say I have g of x, and it is given by square root of 4 minus 5x. What is the derivative of g? So if you're going to use 4-step rule this time, you know 4-step rule, guys? Are you familiar with this, guys? Actually, this is also limit definition, but instead of going directly to limit, we have 3 steps more before going to limit, okay? So the operations that you are doing inside the limit, so you're going to do it separately. First 3 steps, we have this, no? But of course, first we let y be equal to g of x. But our g of x is square root of 4 minus 5x. Okay, guys? Children? So, first step, you're going to replace y by y plus delta y. And then, x by x plus delta x. So, getting 4 minus 5 times x plus delta x. Okay? And then after that, second step is solve for delta y. So getting square root of 4 minus 5x minus 5 delta x, then minus y. But what is our y? Square root of 4 minus 5x. Okay? So let us rationalize this radical, okay? Getting square root of 4 minus 5x minus 5 delta x minus square root of 4 minus 5x, I'm going to multiply this by what, guys? By, so what is our multiplier, guys? We multiply by the conjugate, no? Because this is the technique that we are doing when dealing with limits. Because later we're going to have limit of this quotient, okay, that we are going to form, plus square root of, so this plus square root of 4 minus 5x. So this is the conjugate. So we multiply also the denominator. What's the product, guys? In the numerator, we have a minus b, a plus b. So I get 4 minus 5x minus 5 delta x, then minus of the square of this. So minus 4 minus 5x all over square root of 4 minus 5x minus 5 delta x, and then plus square root of 4 minus 5x. Okay? So this is our delta y. Then the third step is to get the ratio of delta y and delta x, meaning we divide this delta y by delta x. So delta y over delta x is equal to, what is the, by the way, when we simplify this, we get what? 5x is eliminated, no? With this negative 5x, because this is 5x. Minus 5x, 0. Negative 4 plus 4 is 0. So what is left in the numerator is simply negative 5 delta x. Okay? So all over this radical square root of 4 minus 5x, then minus 5 delta x plus square root of 4 minus 5x. By delta x, the only factor left in the numerator is negative 5. In the denominator, square root of 4 minus 5x minus 5 delta x, then plus square root of 4 minus 5x. This is negative 5. In the numerator. And then the last step, which is the fourth step, that's why it is a four-step rule. So derivative of g with respect to x is equal to the limit as delta x approaches 0 of. So we take this ratio, no? Take the limit of this ratio. What is the limit of this ratio, guys? So that is equal to negative 5 over square root of, so this is 4 minus 5x. So this is going to be 0 because our variable is delta x, not x, plus square root of 4 minus 5x. Okay? What is now the final answer, guys? What is g prime of x? That is negative 5 over the denominator. So we have in these terms two identical radicals, no? So 2 times square root of 4 minus 5x. That's it. So that's the derivative. Okay? Of course, you can use limit directly if you want. But what will happen is that you are going to keep on writing limit. Whereas here, so you just focus on first inside the limit, no? So these things. So because these are the things that you will be doing if you use directly the limit definition. Okay, guys? So you have an option. You can use this or directly the limit definition. Is that clear, children? Okay, what about number 4? So given f of x is equal to 4 minus 5x all over x plus 3. So find the derivative of this function. So again, I'm going to use four-step rule. So let y be equal to f of x. That is 4 minus 5x all over x plus 3. Okay, guys? So then, the first step is to replace y by y plus delta y. And then x by x plus delta x. Okay? Then, second step is to solve for delta y. So getting in the numerator here, we have 4 minus 5x minus delta x times 5, no? All over x plus delta x plus 3. Then minus, what is our y? Minus y, we have 4 minus 5x all over x plus 3. Let's simplify this by combining these two fractions into a single fraction. Let's scratch here. So I'm going to multiply this by this. This is the LCD, no? X plus delta x plus 3 multiplied to x plus 3. So first multiply this numerator by x plus 3. 4 times x, so we have 4x minus 5x squared minus 5x delta x. And then what about 3? So 12. So put it here, 12 minus 15x. So align it here, 15x. And then minus 5 delta x times 3. So 15, no? 15 delta x. Okay? And then what about this one? 4 minus 5x is multiplied by x plus delta x plus 3. But take note, preceded by negative. So whatever the product, you're going to change the sign of its term. Okay? So let's have this. 4 times x. So that is 4x. So negative 4x. We reverse because preceded by negative. 4 times delta x. So 4. So negative. So align it here. Then negative 12. Negative 12 here. What about negative 5x? Negative, negative. So positive. So everything is positive. So 5x times x, 5x squared. Here. And then we have 5x delta x. So it's here. Last now, 5x delta x. Because preceded by negative, negative, positive. Everything is positive. 5x times 3, 15x. So I'm going to put it here. Okay, guys? So, am I clear with this? Let's combine similar terms. So this is 0, 0, 0, 0, getting what? Negative 19 delta x. Am I right, guys? So therefore, what is our delta y, guys? As a single fraction, we have the denominator is x plus delta x plus 3 multiplied to x plus 3. The numerator is negative 19x. Delta x, I mean. Negative 19 delta x. Okay? Then the third step is to get the ratio of delta y and delta x. So meaning delta x is canceled out. So getting negative 19, denominator is still the same. So that's now the ratio. We call this actually what, guys? What do you call that, guys? Number 3. What about number 3? Guys. Do you have any question with number 3? Okay. Let's continue. So again, how do you interpret delta y over delta x, guys? That is average rate of change. Okay, children? We call this average rate of change. So if you take the limit of this average rate of change as your delta x approaches 0, that is now instantaneous rate of change. Sometimes simply rate of change. Okay. So again, what is g prime of x? Or that is the derivative of y with respect to x. So it is equal to the limit of this ratio, no? As delta x approaches what? 0. What ratio? So the denominator is x plus delta x plus 3 times x plus 3. The numerator is negative 19. So evaluating the limit, what is that, guys? This is x, limit of delta x as delta x approaches 0 is 0, no? Plus 3 multiplied to x plus 3, numerator negative 19. So that is g prime of x. Finally, what is g prime of x, guys? Negative 19. The denominator has factors that are identical, no? So x plus 3 quantity squared. Any question with this, guys? Guys, any question with that? You can use limit definition, if you want, the direct one. What do you think? Which one is a better one? The direct definition, meaning limit definition of derivative, or something like this? Guys, what do you think? At least here, you don't write many limits, no? You don't keep on writing limits. And you are doing the simplification of the function inside the limit, no? Gradual. Okay? On number 5. But this time, we are going to have the given, let's say f of x is equal to 4 over x. Find the value of the derivative when x is negative 2 using limit definition. Let's use limit definition here. Although if you use formula, of course you can get easily the derivative of this and then find the value when x is negative 2, no? But by increment method, making use of limit definition, we have, again, what is f prime of x using limit definition? Limit as delta x approaches 0 of f of x plus delta x minus f of x. Denominator delta x. So this is equal to the limit as delta x approaches 0 of, what is our f of x plus delta x? I'm going to replace 4 by what? I mean x by x plus delta x, no? So we have 4 over, this x is to be replaced by x plus delta x, okay? minus, what is f of x? 4 over x. Okay, guys? All over delta x. Well, let's simplify this quotient. What is our multiplier here, guys? In order to simplify this complex, we multiply this by x plus delta x times x, no? Both the numerator and denominator. Okay? So getting in the numerator, we have 4x for the first term. Second term is minus 4 multiplied to this. So 4x minus 4 delta x. The denominator, we have x plus delta x. So 4x is eliminated. So we just have negative 4x delta x here. And delta x is cancelled with what? With the delta x. I think I missed the delta x here. There is another factor in the denominator. Okay? So that is cancelled with this. Oh. We are now left with this expression here inside. Simply negative 4, no? Over x plus delta x. Can we now get the limit of this, guys? Yes, no? Let's evaluate now the limit. So that is negative 4 over x, no? X plus 0. Oh, this is equal to what? Negative 4 over x squared. So that's the derivative. But what's the value of this derivative when x is what? When x is negative 2. Guys, all we have to do is to what? Replace x by negative 2, of course. Negative 4 over negative 2 quantity squared. And this is equal to negative 1. Am I right, guys? Guys?
Yes, sir.
Now, of course, there is a direct way of getting this. Am I right? But there is an option if you have a particular value of x, your x sub 1 or your x sub 0 or your a, your c. So depending on the notation introduced to you, no? So alternatively, we have f prime at a. I'm using a instead of x sub 0 or x sub 1. If you have a particular value of x, so we have limit as x approaches a of f of x minus f of a. Do you have this, guys? Do you have this formula, guys? Guys, denominator x minus a. So meaning I'm looking for f of negative 2. My a is negative 2. What is my f of x? My f of x is 4 over x. What is the value of the function when x is negative 2? That is negative 2, no? 4 over negative 2 is negative 2. All over x minus 2. But x minus negative 2. So x plus 2 na. Okay? Am I correct, guys? Multiply this by x over x to simplify this quotient. Getting limit as x approaches negative 2 of, this is 4 minus of plus now, no? Plus 2x all over x plus 2. Okay? I think we can cancel x plus 2 here, no? Because this part is what, guys? This is x plus 2 times what? Times 2, right? So meaning, I can express this as what? Limit as x approaches negative 2 of simply 2 over x. Am I right, guys?
Yes po.
Okay. So, what's now the value of this limit as x approaches negative 2? So, it is 2 over negative 2 that is equal to negative 1. Get it, guys? So, if you have a specific value of x, you can make use of this formula for the definition of the derivative. Okay? Next one, given, let's say f of x is equal to x squared if x is to the left of negative 1. And then I have 2x plus 3. I don't know. Plus minus 1. If x is to the right of negative 1. Let me check. What about that? Guys, what is the given function, guys? Piecewise function, huh? Guys, I want to find f prime of negative 1. Now, let's see if the derivative of negative 1, the derivative of f at negative 1 exists, no? So how to determine if f prime of negative 1 will exist, guys? Anyone? Guys?
Sure,
You have to
the
compute for what?
left
Since
hand.
it is piecewise, there is to the left and to the right ng negative 1, we have different expressions defining f of x. So we're going to get what? Left hand and right hand derivatives. Am I right?
Yes, sir.
So what is the first derivative of at negative 1 from the left? F prime of negative 1 from the left. So how do we define that? Limit as x approaches negative 1 from the left of f of x minus f of negative 1 all over x minus negative 1. What is my f of x if it is to the left, guys? Guys, what is my f of x if it is to the left of negative 1? X squared, right? What about the value of the function? Take note, this is the value of the function. What's the value of the function? Guys, what am I going to use? Is it the first expression or the second one? Defining f of x. The second one, no?
Oh.
-2 minus 1 because x is -1. What is the value? Is it -3, guys? All over x plus 1. So limit as x approaches -1 from the left of x squared plus 3 all over x plus 1. Okay? So the numerator approaches what, guys? -1 quantity squared plus 3 approaching 4. That's the limit. What about the limit of the denominator? Approaching 0 through what? Through negative or positive, guys? Guys, through negative, no? Okay, guys? What is now the limit? Positive infinity or negative infinity? Negative infinity. So the derivative of f at x equals -1 from the left is negative infinity. So since the limit from the left does not exist, so automatic this derivative of f at -1 does not exist. Am I right, guys? So no need actually to continue. Okay? But if you want to complete your solution, so you may do so, no? Okay, guys? So from the right, we have limit as x approaches -1 from the right of f of x minus f of a all over x plus 1. So I have limit as x approaches -1 from the right. What is my f of x? This time from the right to x minus 1, no? Then what is my f of a? My f of a is what, guys? Ang a ko, -1, no? Okay? So f of -1 is still -3. All over x plus 1. That is x minus -1. Limit as x approaches -1 from the right, we get, guys. Oh, guys, what's the derivative? Guys. Sorry. What's the simplified form? This is 2x plus 2, factoring out to x plus 2 plus 1. Na? All over x plus 1. So this is canceled out. So what's now the limit? Equals 2. So that's the value of the derivative of f at x equals -1 from the right. So it exists from the right, but from the left, not. Therefore, our conclusion, f prime does not exist, no? If the limit from the left, if the derivative from the left is not equal to the derivative from the right, this implies what, guys? F prime of -1 does not exist, meaning f is not differentiable where, guys? At x equals -1. Get it, children? Guys? Guys?
Yes, sir.
Alternatively, what is the option for this, solution for this? Guys, do you have any option to solve this? Let's say you check for continuity. Check for continuity. Check for continuity of f at x equals -1. Okay, guys? What is the value of the function when x is -1? It exists, no? And that is equal to what? What did we get? -3, right? What about the limit as x approaches -1 from the left of f of x? We're going to use x squared, no? And what is that? 1. Am I right, guys? From
Yes,
the
sir.
right, what's the limit, guys? Limit of f of x as x approaches -1 from the right. We are going to use what, guys?
Second expression.
2x minus 1, no? And what is that limit? You can do it mentally. -3. So, meaning the limit does not exist, no? Okay? So what conclusion can we get? So f of -3 is not equal to the limit of f of x as x approaches what? -1, which implies that discontinuous where? What is the implication of this? F is discontinuous at what? At x equals -1. So therefore, if f is discontinuous at a number, automatic, it will no longer exist for its derivative. Am I correct, guys? Guys. So therefore, we conclude that f prime at -1 does not exist. If a function is not continuous at a given value of x, then its derivative does not exist at that number. Am I clear with that, guys? Guys,
Yes, sir.
what if a function is continuous at a number? Is it a guarantee that it will be differentiable at that number? Guys? Guys? Let's say I have f of x. And that is equal to, let's say, my x is, my f of x is square root of x minus 5, if your x is to the right of or equal to 1, no? So I think it's not. So let me have 5 minus x. 5 minus x if x is to the right of 1 or to the left. To the left na lang ng 1. Para no problem. If my x is to the left of 1, including 1, so I have square root of 5 minus x. And then if my x is, let's say, x squared, if my f of x is x squared, if x is to the left ng 1, yan, find f prime at 1. What do you think? Ano-anong mga option natin? What are those options to determine the existence of f prime of 1? Guys. You can check what, guys? Continuity, no? Check for continuity first. Kasi if x is not continuous, if f of x is not anymore continuous when x is 1, therefore no need to continue, guys. Okay? Check for continuity. At x equals 1. Now, what is f of 1, guys? So we use the first one, no? Square root of 5 minus 1. That is 2. What about limit? As x approaches 1 from the left. Oh, what's the limit of f of x? Actually, still 2, no? Limit as x approaches 1 from the right. Times 2 ko to. Because I want to be continuous this time. So that is times 2. So 2 times 1, that is also equal to 2. So meaning continuous, no, guys? Am I correct, guys? I modify the problem, guys. Continuous at x equals 2, no? Is it a guarantee that it is differentiable at x equals 1, guys? What do you think? Can we conclude immediately that it is differentiable at 1 and then just find the value? What do you think, guys? There is only a chance, no? But not guaranteed that the derivative will exist at x equals 1. Am I right, guys? Children? So it's not a guarantee, but at least there is a chance. You can proceed. But if it is discontinuous at x equals 2, no need to get the left derivative, right-hand derivative. No need. Okay? But if you are, what you call this? If you have so much patience, go ahead. Okay? So let's check, no? Dahil continuous, there is a chance. What is the derivative from the left? Anong derivative from the left? Equals limit as x approaches 2 of f of x minus f of 1 all over x minus 1. As x approaches 1. Approaches 1, not 2. Let's proceed. Limit as x approaches 1. What is f of x? We're going to from the left, no? From the left of 1. So we're going to use the square root. What is the value of the function? We got that already. 2. So minus 2 all over x minus 1. Okay? So we multiply this to get the limit because this will be 0, 0, no? So indeterminate. Okay? So this is indeterminate. Limit as x approaches 1 from the left of square root of 5 minus x, then minus 2 all over x minus 1 times. My multiplier is the conjugate of this numerator, 5 minus x, then plus 2 all over square root of 5 minus x, then plus 2. Okay. The numerator now becomes 5 minus x minus 4 all over x minus 1 square root of 5 minus x, then plus 2 here. Okay? No. The numerator is negative x minus negative x plus 1, no? So meaning this numerator is what, guys? It is, what is this numerator, guys? This is negative of x minus 1. Am I right, guys? Or negative x plus 1. So I can get rid of that, no? This x minus 1. So getting limit as x approaches 1 from the left, what is left in the denominator is square root of 5 minus x, then plus 2 here. This is simply negative 1. Okay? What's that, guys? What's the derivative? Now, we can now get the derivative from the left of 1. Negative 1 over, so going to be 2 plus 2 here. This is negative 1/4. Get it, guys? What about from the right? Derivative of f from the right of negative of 1, no? Limit. So this is what we are solving. No? Approaches 1 from the right, f of x minus f of a, x minus 1, the denominator. But what is our a, guys? 1, no? All over x minus 1. Or limit as x approaches 1 from the right, the numerator is 2x squared because I think may mali ako sa given. This is from the, you are not checking my problem. Okay, guys. Because this is not a function if x is to the left also of 1. Okay? So to the right, we have 2x squared plus, minus f of 1. What is f of 1? Still 2, no? All over x minus 1. Okay? What is this, guys? This is equal to the limit as x approaches 1 from the right. What is left? Factor out 2, we get the remaining factor x squared minus 1. So it has a factor of x plus 1 and also x minus 1, no? So cancel with this. So getting 2 times x plus 1. Am I right, guys? Guys, what's the limit? 4. Okay? Guys. Children. Am I correct, guys?
Yes,
I don't
sir.
think I.
Yes,
Yes,
po.
I thought you are no longer there. To factor out, let me check again because you are, I think, sleeping because later you might say there is something wrong. Okay. The limit, the derivative from the left, derivative from the right at x equals 1, they both exist but not equal. What is our conclusion, children? Therefore, f prime at 1 does not exist. Clear, guys? There's a question here. sa piecewise lang po ba di guaranteed ang differentiability kapag continuous? Hindi. Maring continuous siya at a number, pero what you call this? Let me check. Pero hindi siya differentiable. Meron kasing mga function, not piecewise, pero may sharp point. Kagaya ng ganito, guys. Yan. If you have a point like this, normally nakakakuha tayo ng mga sharp point. Pag fractional ang exponent, halimbawa x to the 1/3, yung mga ganyan. X plus 1 raised to 2/3. So there are functions like that. Doesn't mean na piecewise lang. Hindi nagiging differentiable ang function at a given value of x. Okay, guys? So continuity does not guarantee that it is differentiable. Okay, children? Next. Given. Yan. We have x squared if x is less than 0. X cubed if x is greater than or equal to 0. What about this? Check natin if this is differentiable sa 0, no? Question, is f differentiable at x equals 0, guys? Meaning, if so, let's say, if so, sabihin natin. If so, find f prime at 0. Ano daw yung f prime at 0? Okay? Guys? First, is it continuous? Actually, by inspection, you can get easily if it is continuous or not. Na, guys? Am I correct, guys?
Yes, sir.
Continuous, so we can still proceed, meaning there is a chance, na? Continuous at x equals 0. There is a chance to be differentiable. There is a, it's not guaranteed that it is differentiable. Clear, guys? Continuity does not guarantee that a function is what? Is differentiable. But if a function is differentiable, guaranteed that it is continuous at that number. Okay, guys? So, first we get the derivative from the left. What's the derivative from the left? Limit. What is my f of x from the left? X squared, no? Value of the function from the left, 0 over x minus 0. X approaches 0 from the left. What's now the limit, guys? Anyone? What's the limit from the left? 0, no? Therefore, what's the derivative of f from the left at x equals 0? 0. Am I right, guys? What about limit? I mean, derivative from the right or at x equals 0. So that is equal to the limit as x approaches 0 of, so from the right, no? What is our function? X cubed. Value of the function is still 0. By the way, be careful ha sa function value at sa expression defining f ha, kung sang direction tayo. Ang function value hindi nagbabago kung nasaan yung actual value ha. So we have limit of x squared, no? As x approaches 0. What's the value, guys? Guys, 0. What conclusion can we get? Since f prime from the left is equal to f prime from the right at x equals 0, this implies that the derivative at 0 exists. Okay, guys? Anong ibig sabihin nun? F is what? Is differentiable at 0, right, guys? Children? Children?
Yes, sir.
What's the value of the derivative? 0. Get it, guys? Any question with this, children?
None, sir.
Do you now understand? Guys?
Yes, sir.